Hey everybody, it's Clancy with HKN, and today I'm going to talk about rectangular coordinates and polar coordinates. So let's say you're given a voltage V equals M with a phase shift of theta. So that would be V equals M with a phase shift of theta. This is polar form, so we can write it in terms of E. So we'll have V equals M e to the j theta. We're just going to take this as a given from here to here. You can look it up in a math book if you want. If you remember from Calc 2, Euler's identity I think it is, we can turn e to the j theta into cosine theta plus j sine theta. So if we write that out, we're going to have V equals M times cosine theta plus j sine theta. And if we distribute the m, we'll have m cosine theta plus j m sine theta. Just a quick bookkeeping note, you should keep the j in front, at the very front of a term. That way when you're looking through your problem and you're like, oh, what's real, what's imaginary, it's crystal clear right off the bat. Rather than writing mj sine theta, you should write jm sine theta. So now that we have our voltage, note we went from polar form to rectangular form. Let's see if we can gain a little intuition about this. So if we wanted to graph this, like an XY type thing, a natural choice for the axes would be real and imaginary. Reason being, this is real and this is imaginary. This is real because there's no j in there. Simple. And then this is imaginary because there's a j. So let's draw the axes. So we're going to have the real axis, and then we'll have the imaginary axis. And let's just plot them. So the real part is m cosine theta. So let's say that falls like right there. M cosine theta. And then the imaginary axis assumes that you have a j in your term. So we can forget about that j for right now. And then we have m sine theta on this axis. So we'll have, let's say it goes right there, m sine theta. And if you connect the dots, you'll see that this point is A, comma, B, where A is m cosine theta and B is m sine theta. Or if you wanted to put it in polar form, you could say, okay, how long is this line? Well, it's m, and then the angle is theta. And if this side is A and this side is B, I think you can use Pythagorean's theorem to find m. So that's just a quick overview of how you can go from polar down to rectangular, or you can just follow the steps back up and get the other way. And this will be helpful in the problem that we're about to do on AC steady state.